Hello, welcome to 5-Minute Maths. Today we'll be going over infinite geometric sums. Now before we start the video, I would like to remind you guys to subscribe and turn on the notification bell for more quality content. Now let's get on with the video. So how do we actually add an infinite geometric sum? Like in the geometric series, we have an infinite amount of terms. So how do we actually add something like that goes on forever? So I'm going to show you a very basic example. We can have the series 1, 1/2, 1/4, 1/8, and so on. So this is a geometric series. Well, we can first represent the 1 as 1 whole square. So if the 1 is 1 whole square, then 1/2 could be represented as 1/2 of a square. So this is 1/2 of a square. And then if 1/4 should be 1/4 of a square, then 1/8 should be 1/8 of a square. Then 1/16, the next term in our series pretty much should be 1/16 of a square. And now you see what's going on here. As we progress down our series, we're just starting to fill up this gap right here because it'll just decrease proportionally every time we move down our series. So since we have an infinite amount of terms, this gap right here will be filled up. So we can say that since we 1 whole square is representative of 1, we say this is 1. And since this gap will be filled up, and since we have 1/2 and 1/4, then this will be 1 whole square. So just 1 plus 1. And that equals to 2. So the sum of the series 1, 1/2, 1/4, 1/8, all the way to, we don't know, will be 2. So that was pretty much a little intro into adding infinite geometric sums. But now I want to show you the formula. So the formula for finding the sum of geometric sequences is a divided by 1 minus r, where r is a common ratio. And it says that r is greater than -1 and smaller than 1. This is because in order to derive this formula right here, r has to be a fraction or a decimal, and also r is non-zero. Because, for example, if the r is just pretty much a common ratio, if r, let's just say, is not a fraction, let's just say it's 3, in our geometric sequence it's just 1, 3, 9, and so on, then it's just going to approach infinity. Like, we can't calculate the sum just approach infinity. So that's why it has to be a fraction. And I'll show you why in order to derive this formula, r has to be a fraction. So you should know that the sum of just for partial sum of geometric series is the formula is a times 1 minus r to the n divided by 1 minus r, where a is the first term and r is a common difference, and n is the number of terms. So in order to derive a divided by 1 minus r, and let's just first assume that our r is a fraction, because I just said r has to be a fraction, right? So we have an infinite amount of terms, so n should be infinity, right? Any fraction to the infinitieth power will eventually approach 0. So this portion, let me circle, this portion right here should approach 0. So therefore 1 minus 0 is 1. So a times 1, just a. So the top is just a. And that is where we get a divided by 1 minus r. So now you see that r has to be a fraction. So now let's do some practice. So first let me erase. Okay. So let's practice. Okay. So we want to find the sum of this geometric sequence. 3, 1/3, 1/9, and so on. So first, let's identify our first term. Our first term is 3. So we can first plug that in our formula. Our formula is a divided by 1 minus r. So a is our first term, so 3 goes up here. And now 3 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. So we know r is 1/3 because we're simply multiplying by 1/3, or we can just say dividing. But in this case, we want to have fractions, so just say multiply by 1/3. So just 3 divided by 1 minus 1/3. 1 minus 1/3 is 2/3, so simply 3 divided by 2/3. Now, since it's divided, we could just simply just flip the reciprocal. That'll just be 9/2. So that's our answer. That's it for this video. Hopefully you guys enjoyed, and if you did, please like, share, and subscribe. If you didn't find it helpful, please roast us in the comments and leave us some suggestions on how we can improve. Thanks for watching.